Hi everyone, in this video we'll learn how to find the factor tree of 64. Factor tree is used to find the prime factorization of any given number. Why we got this name factor tree? Because we'll split 64 and it will form a branches. Let's see how to do it. First we'll write 64. Now we have to split the 64 in such a way that when I write the two factors of 64, and when we multiply these two factors, I should get 64. So we have to find two factors of 64 in such a way that when you multiply, you should get 64. Now, in other words, you can use a times table, like from 2 to 10, that is sufficient, in which all times table we get 64. 64 is an even number. It goes in 2, it goes in 4, and it goes in 8. Right, 8 times 8 is 64. We can use anything. If you want to use 2 times table, 64 is divisible by 2. So 2 times 32. If you do, you get 64. Now, if you have a doubt how which number we should multiply to this 2 to get 32, to get that answer, you can divide 64 by 2. You get 32. And we can also use 4. So 4 times 16 is 64. Then 8 times 8 is 64. So there are many numbers which multiply to give you 64. You can choose any one. Let's assume that we have taken 4 times 16. You can pick any one. You have to just split it such a way that when you multiply these two numbers, you can see that 4 is a factor of 64, 16 is also a factor of 64. When you multiply these two, you get 64. Right? You have to split in such a way. Now, after splitting, you have to check if the numbers you have written is a prime or composite. If it is prime, circle it. The branch will end there. It will not split again. Here 4 and 16 both are composite numbers, which means we can split them further. We can split 4 because 4 is a composite number. So, how can we write 4? 2 times 2 is 4. So, we can split 4 in this way. Similarly, how can we split 16? Now we can write 16 in different ways, like 4 times 4 is 16, 2 times 8 is 16. So it's completely on you. Let's take 2 times 8, 16. So 2 and 8. Now stop here and check if numbers are prime or not. 2 is an even prime number. So we got prime number, we circle it. We cannot split this further. This means the branch will stop there. But we can still split 8 because 8 is a composite number. How can we write 8? 2 times 4 is 8. So we can split in 2 and 4. We got 2. 2 is a prime number. Circle it. Next we have 4. Split it. 2, 2. 2 times 2 is 4. Circle it. That's it. Now we have obtained all the prime factors of 64. So how can we express this? So 64 is equals to, you have to multiply all the numbers in the circle. We got 2 here 6 times. You can count 2. Number of 2's here are 6. So 2 times 2 times 2 times 2 times, so last one more 2. This is the prime factorization of 64. We can be able to express 64 in terms of its prime factors. Now you may ask, is this only the factor tree of 64? No. You may get different factor tree. For example, if we split 64, let's take 8 and 8. Now both 8 are composite numbers, right? 8 and 8. We can split them further. We can split 8 as 2 times 4. Similarly, this 8 as 2 times 4. 2 is a prime number. We'll circle it. And 4 is a composite. We can split it further. We can split it as 2 and 2, and this 4 also 2 and 2. Now we obtain 2 here. 2 is a prime number. We cannot split it further. We'll circle it. Now if you see here, how many 2's we got? 1, 2, 3, 4, 5, 6. It is same as what we obtained before. So prime factors you obtain will be same, though the factor tree will look different. So it doesn't matter how it looks, but the prime factor what you obtain will be same. So this is how you can use factor tree to find the prime factorization of any number. If you have further question or doubt, you can drop a comment. Thank you so much for watching.